This video is for my calculus class. I apparently need to explain. Well, for some reason, it'll be easier to explain the discussion that we're doing on antiderivatives, integrals, and integrals involving EU and logarithmic. We're using the substitute. It'll be easier to explain while talking. The professor went through it perfectly fine, but I guess so I'm just going to use this video for my discussion post. I want to get a grade on this, and I'm having a hard time explaining it with typing. I've sent screenshots, but apparently it's not enough. Anyway, so to say my professor, I found a few things that he obviously, because when it comes to math, I'm just discussing what I thought. I haven't called the tutor to ask these. Sometimes I do, but I haven't called them yet. So this one's very straightforward, to the point, whatever. So we're going to the substitution method, which I found a few things, but it's a substitution method. Everybody's done that in like a linear algebra. So for me, I see he used, so we have du 2dx. We didn't have this initially. He moves his dx down, I think, from the u here, because we need to have a leading coefficient here because we have to substitute this with this. So I think that's what he used. He used the formula to do that. Yeah, oh yeah, u is 2x. This is 2x. So sorry. Anyway, so that's what that is, right? So u is 2x. Anyway, oh, this is the same one. The u is x3 here, u is here. The 3. Oh, this is just a du. So du is already 3x2. This is already that equation. Now, in order to substitute, he has to bring this and put it on the outside of here. The normal leading coefficient is always 1. So this is always 1 that I noticed. That comes out to that. This one, because it's a numerator, this one I had to check. So I think because the equation here is a numerator, it doesn't have to do that. We use the default leading coefficient of 1 because there's always a leading coefficient of invisible. Leading coefficient of 1 in front of each of every variable. So we use the 1 we did here. He used the 4 out here. Where am I going? Right, so the 4 is out here. And this turns to... Right, so now this is, since it's the regular one, it's just du over u, because these are our values. And that goes up to 4ln. That makes sense. Beautiful. We're done. Okay, anyway, so here we've got x2, and these are the two x's here. So the x squared, and this is an x and an x. I think these are both just identified as themselves. And then, and this is just in the equation in the inside. And in order to substitute this one, I think since this is easier, this goes into each other, he used the 6 for the du on the outside of here. Now, I'm not that one. I have to look at how he decides that.